What's up guys, Shawnthebro here, and in today's episode of the Super Smash Brothers and Platform Fighter tutorial series, we are going to be going over controller and keyboard input on the character select screen, and really for all your menus, but we're going to specifically do it for the character select screen. So up to this point in the series, we did have the ability to use the mouse for menu options, such as on the main menu, and we had the ability to use keyboard inputs to swap between our buttons. That was all well and good, but the character select screen works a little bit differently than the regular menus. We don't have assigned buttons that we can go to. We want to control this cursor. With the mouse, it's really easy. We control the cursor. We can just go to where we want. However, we may want to use the keyboard to control the cursor, or a gamepad as well, which I'll show you later. And this is really useful because A, you may not want to use a mouse in your project, or B, you might be on a platform that doesn't have a mouse. So you want to be able to control this screen with actual game inputs. And I can do everything that I do normally. This is all with keyboard, so I have my little token. I can even place my token and select my character just like usual. When I'm ready, I can come into the game. And when we play it, you see the characters are set correctly. But that's what we're going to be covering today, using the keyboard and controllers to control the character select screen and the stage/level select screen. That way you don't have to use the mouse if you don't want to. The mouse, of course, still works. This is just additional to that. Now, if you want to get caught up in the series before you watch this episode, feel free to check out this link in the top right corner right here. This is the entire playlist of the Super Smash Brothers and Platform Fighter tutorial series, so you can see how we've done things like attacks, hitboxes, items, stock, and much more. Alternatively, if you only care about the keyboard and controller input on this menu, I recommend you watch this episode right here, which is where we initially set up the behavior for the character select screen. With that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series, but everything we need to do is going to be in blueprint today. The first thing we want to do is go to our project settings, so edit, project settings. We want to scroll down to input, and we want to take a look at our input actions. Now, if you've been following the series directly, you will have a menu left and a menu right. And this is what I was showing you earlier on the main menu. We could use these to actually navigate the menus, but we can use them for more than that now. So if you don't already have these two input actions, menu left and menu right, make sure you add two now. You can technically use your regular input axes or other input actions that you have for movement. But I like to have some for the menus because if the player changes their controls, we still want to have some way to navigate the menus, and we may not want to lock them out if they set their controls to something ridiculous that they can't use. By having default controls, we always allow them the ability to reset and fix any mistakes with binding their own controls. So quick recap, menu right was the D key on the keyboard, and menu left was the A key on the keyboard. I've also added two new input actions today, and I've called them menu up and menu down. Menu up is the W key on the keyboard, and menu down is the S key on the keyboard. Again, you could do these with input axes as well, so the axis mappings. It's up to you. I wanted a consistent movement when I was using my controller and keyboard, so I made them input actions, but if you want to make it scale with how far the stick is pressed over or something like that, you could definitely use an axis mapping. And that would clean that up really quickly. So I'm going to minimize this for now, and we can go to our character select screen. This is my character select screen. Nothing has changed in the design view. Let's go to the graph. Now in the graph, I'm going to go to the event construct. Earlier in the series, we set it up to where we set the input mode, and we started listening for the menu grab coin. I've added a lot of listen for input actions. We'll go over this in a second. After that, we set the game instance reference, determined if we should show the mouse cursor or not, and determined how many players there were. So everything that was in here before is still in here. The only thing I did was add more listen for input actions after the first one. So basically, we're going to add a new call to listen for input action. And for the action name, you're going to want to pick the names that you had here. So we need to do menu left, menu right, menu up, and menu down. So grab them, copy them, or just make sure that you translate them correctly. So for the first one, for example, we can do menu underscore left. Then what we need to do is determine what happens when we press this input, because when we start listening for this input, essentially whatever we put in the callback is going to fire when it is either pressed, released, repeated, double-clicked, or determines the axis value. In our case, we're going to leave the event type as pressed, because when we press it, we want to start moving the cursor to the left. I checked consume input for these. It's not required, but consume is basically if you want this to work for multiple objects. So if I press this button and say I'm trying to move and have a menu item open, then I could move the character and then also move menu items as well at the same time. And I don't think we want that here, so I'm consuming input. Then the callback, you just drag off of this and type add custom event. And then we can do whatever logic with it that we want. So I'm going to delete these, go back to what I have here. So I called it move cursor left for the name of the event. Now we could start moving the cursor as soon as we press this button, but remember this isn't an input axis, it is an input action. So if it only fires on press, we want to really just tell the system that we are pressing that direction. And then on release, we want to tell the system we are not pressing that direction. And whenever that direction is being pressed, we'll move the cursor in that direction. So what I've done is made 4 new variables. So plus variable to add them here. And I made is pressing left, is pressing right, is pressing up, is pressing down. Now, right now, this is all for one player in that system that we have. So we technically have multiplayer support on this menu, but it's all through one input device. In the next episode, we'll go over converting this to support multiple players on one device. But for now, we just need 4 booleans, just if the player that owns this widget is pressing left, right, up, or down. Once you've made these 4 booleans, you can leave them all as defaulted to false, because by default, when we come into the widget, none of these are being pressed. Then, once our variables exist, in move cursor left, we can drag and set is pressing left to true, because menu left has been pressed. And that's how you get what I have here. Now, the next few nodes are going to be very similar. So we're going to do a listen for input action for menu right. It's going to be on pressed and consume, and we're going to make a new event called move cursor right. In this event, we're going to set is pressing right to be true. Then I have listen for input action for menu up. It is pressed and it consumes. I call an event called move cursor up, and it sets is pressing up to be true. Then I have a listen for input action with menu down, pressed, and it consumes input. We add a custom event. It's called move cursor down, and it sets is pressing down to be true. These 4 are all the press listen for input actions. Now I have 4 other ones, and they are the release input actions, because when we release those input actions, we want to say we're no longer pressing that direction. So now I have listen for input action, menu left, but this time I changed the type to be IE released. I still consume input, and then I make a custom event called release cursor left, and we set is pressing left to be false. After that, we have a listen for input action for menu right, released, consume, calls an event release cursor right, which sets is pressing right to be false. I have another listen for input action for menu up that is released and consumes, calls release cursor up, which sets is pressing up to be false. And one more listen for input action for menu down. It is type released, it consumes, it calls the event release cursor down, and it sets is pressing down to be false. Now, it's a lot of setup, but it's pretty simple. After doing that, we will track if the player is pressing left, right, up, or down, or if they've released it. And if they are pressing it, we need to determine what to do after that. What we want to do is actually move the cursor in the given direction that the player is pressing. So now I want to go somewhere else in my graph, and I'm going to go all the way to the bottom, and I'm going to make a tick function. Rather, I'm going to just handle the tick event or tick function that we have here. We don't have to make our own. We can just use the one that's built into the widget. So we didn't need to use this to this point in tutorial series. So we can grab the event tick here for the first time. So event tick, just type it in and you'll get this add event user interface. I've already done it, but when you press that, it will add this node right here. And tick fires every single frame. So every frame we're going to check for if the player is pressing left, right, up, or down. And then if they are, we're going to move them a certain amount. So this is very simple. At this point, we're going to grab all of our booleans. So let's start with is pressing left, and we're going to drag it and get it, and we're going to put this into a branch. If it is true, then we are going to call a function that moves the cursor. But we don't have this yet. So let's go ahead and make it, and then we'll come back to tick, and then we'll fill out this event, because this is the most complicated event in this episode. So let's handle that last. But let's make the event. So I'm making a custom event called move cursor. So I can do this by right-clicking, add custom event, and again I call it move cursor. I'll call this one move cursor 2. Now once we get this event, we can add some input parameters to it, and we're going to want to know if the movement that we are trying to perform on this menu is horizontal or not. And we're also going to want to know the direction. So we want to know if it's horizontal, left or right, and if it's not horizontal, up or down. Let's go ahead and add a new input. We're going to leave it a Boolean and say is horizontal movement. Then we're going to add another input parameter, and we're going to make this one a float. I'm going to call it direction. You could also call this something like amount or whatever, because this is how much we want to move in each direction. The reason I call it direction is because if we have negative 100, for example, we're moving negative 100 units every frame. Well, the direction of negative, if it's horizontal movement, is to the left. The direction of positive, if it's horizontal movement, is to the right. So it really does determine the direction, but it's the direction and the amount put together. Once you've created your event, mine is just called move cursor, we can go ahead and call it here. So is pressing left. If this is true that the player is pressing left, we want to call move cursor. And we can start filling out this data. So left is horizontal movement. And the direction, you can use whatever speed you want, but it should be pretty small since it's getting called every frame. So I chose -10. Now, even if the player is pressing left, we want to check for things like is pressing right, because the player could be pressing both these directions at the same time on a keyboard, so it's best to check for all of them. So if it's true and we call move cursor, we still need to go into the next branch where we check is pressing right. Also though, if it's false that they weren't pressing left, that doesn't mean that they couldn't be pressing right. So the false also has to go into this branch. And you can see that's what we've done here. We have is pressing left branch, move cursor. Each path goes into the next branch for is pressing right. It calls move cursor. It is still horizontal movement, but the direction is +10. Left was horizontal and -10. Right is horizontal and +10. Whether it's true or false, we go into the next branch and we check is pressing up. If that's true, we call move cursor. It is not horizontal movement, so that is unchecked, and the direction is -10. When it comes to vertical values on a widget, the top left is 0, 0. So as you go down, the number goes up, meaning that to go up, you have to subtract a value. So the direction is negative when going up and positive when going down. So in this case, is pressing up, horizontal movement unchecked, direction -10. Whether it's true or false, we go into the is pressing down check, put that into a branch. And if it is true, we call move cursor with is horizontal movement unchecked in direction of +10. So now we are calling the correct function or event whenever a player is pressing a direction. And it works for multiple directions. Like you'll see, I can press down and right at the same time, or up and left at the same time. If I press left and right at the same time, I don't go anywhere. And if I press up and down at the same time, I don't go anywhere. So everything is working as intended. Now we have to fill out the move cursor event. So go to your event from earlier that we just created. And in here, we need to basically determine where the current mouse position is, because that's what our cursor goes off of, and then update it based on the values we gave it from the tick function. Now, it is possible to not use your mouse at all and make another actor or widget to handle this behavior, but using the mouse is honestly fine. It works for keyboard and computer, but it also works for gamepad and other devices as well. So it's perfectly safe to do this, regardless of your platform. The first thing we want to do is get the current position of the mouse, because we can't really update it properly unless we know where we are already at. And there is a function to do this in widgets. There's a widget layout library that exists, and we can just call get mouse position on viewport. If you do it on the viewport, it will change with the size. So, for example, if I play my game, okay, I can move it around. Let's make this bigger. I can still move it around. That's important because we still want to be able to move it around regardless of the size of the window. So getting the mouse position on the viewport is really important. If you don't do it on the viewport, you can do get mouse position on platform, and this will still work, but the difference is this gets the absolute desktop location of the mouse. That's what it says in here. And basically, if you're not focused on the widget at all and way below it, it will still track that. That's perfectly fine, but we don't really want to be able to go outside of the bounds of that anyway. So we don't need that one. And then there is a get mouse position scaled by DPI. But we're going to do our own math here and logic to make sure everything works the way we want. So really we just want get mouse position on viewport. This returns a vector 2D, and basically that is the X and Y position of the mouse on the viewport. And so we can drag off the return value and type break to actually get the X and Y values from it. That's what we've done right here. So break vector 2D, and really all we have to do is add the direction that we passed in to the current X and Y value, right? So if we take X plus the direction, then we'll be good to go. But not quite, because there's a few things we need to do here. First of all, we need to determine if it's horizontal or vertical movement. If we always add the X and Y directions together, regardless of if it's the correct type of movement or not, we will always move up or down and left or right. We won't be able to do just left or right or just up and down. We'll be doing both, and we don't want to do that. So that's one thing we need to look out for. Additionally, notice how this says, gets the platform's mouse cursor position in local space of viewport widget. We need to take into account the scale of the viewport, because if we don't, it's going to be a little bit off. So we'll actually go to the wrong values if we are not careful. There is a node to do this. There's a get viewport scale node that gets the current DPI scale being applied to the viewport and all the widgets. And this will solve our issue of scaling. So let's take a step back and let's use our break vector 2D, and let's actually multiply it by this get viewport scale. Now, when we do this, we will now know the proper coordinates with the scaling included, which is important. So we want to take get viewport scale and multiply it by the X value, and then we want to do this for the Y value as well. So we're going to do another float times float, and we're going to drag the return value from get viewport scale and the Y value into it. So now we're multiplying both these coordinates by the viewport scale. Now, once we do that, now we can add the direction, but we only want to add the direction if it is the appropriate movement to do so. So you can see right down here below, I have these 4 nodes, same as we did above, and then I'm adding them to the direction. However, sometimes I'm not adding them to the direction. Sometimes I'm just passing them in raw from the multiply. This is because if it is vertical movement, we don't want to change the horizontal position at all. If it's horizontal movement, we don't want to change the vertical position at all. And to do this, we can use a select statement. So first things first, let's drag off of our is horizontal movement and bring this into a regular select. When we do this, the Boolean will be part of the index. If it's not, for whatever reason, just go ahead and change it. Is horizontal movement should go into the index. If you're not familiar with selects, what happens here is it reads the result of this index. In this case, it's a Boolean, so it reads either true or false. And then we pass it 2 different values, one if it's false and one if it's true. So if this Boolean returns false, that means it is not horizontal movement, which means it is vertical movement. And in that case, we don't want to update the X value. So we're going to take our result of the X times the viewport scale and pass that into the false. If this is false, we're going to keep our current mouse position. If it's true that it is horizontal movement, take our result from the multiplication and add the direction to it. So we're going to plus, so float plus float, and we're going to add the direction and then pass that into the true. Now this is just for the X value. We need to do the same for the Y value. So we're going to need to do another select statement. And we want to pass the is horizontal movement into it. Now, if it's false that it is horizontal movement, that is vertical movement. So we want to take our result of the viewport scale times the Y and add the direction to that. So it's just the opposite. Plus direction, put this into the false. However, if it is true that it is horizontal movement, we don't want to modify the Y value, so we can take the result of the Y times the viewport scale and just pass that directly into the true. Now I'm going to clean this up, so I'm going to delete all these nodes that we just added, and that's what I have here. That's exactly what I have here. It is cleaned up more here than it was up there, but all this is exactly what you just saw. The select returns a value, and it returns the value of whatever was passed in here that matches the index. So for example, if false was the index, so if it is not horizontal movement, then we use the false value, the value that was passed in this false section, and we're going to return that. If it's true that it was horizontal movement, we're going to use the value that was passed into the true section here. And so both these selects return a value, and we're going to make a new vector out of it. Specifically, we're going to make a new vector 2D that we're going to use for the new position of the mouse. We drag off the return value and say make vector 2D. And you have an X and a Y. So the X is my top one here. So I want to take the return value from the top one, drag that into the X. The Y is my bottom one here. We want to drag off the return value of the bottom one and drag that into the Y. Now, I'm going to right click on my return value on this node and split the struct pin so I get the X and the Y. This is important because we want to round both these values and pass it into the set mouse position function. The set mouse position function does not take in a vector 2D, it takes in an X and a Y, so that's why we want to split it. But additionally, we do want to round these because if we don't round them, our values will be slightly off. Let's actually skip the rounding for now and get this function in the graph. So we want to get the owner of this widget. And right now that's going to be player controller 0. So we can just type get player controller, leave it as player index 0, drag off the return value and type set mouse position. You get an X and a Y value that you have to fill out. Let's say we just passed in the X and the Y directly. If we do, we get these truncate nodes. Truncate just means that it is going to remove any decimals. So if you're at, say, 6.8, it is going to return 6 when converting to an integer. So we have floats for these values, but integers in this function. And since set mouse position isn't a function that we made, we can't really change that. Technically, you could override it or change it in the engine code, but even if you do that, it's going to be a lot more complicated than it's worth. All we have to know is that we are going from float to integer, so we want to make sure that the value is still relevant to us. We don't want to change it too much. So the default of truncate here is going to hurt us. If we actually do this logic, I'll show you what happens. If I press right or press up or down, we're technically moving a little bit to the left, a little bit down each time when we're just pressing those inputs. If we're pressing vertical inputs, we're getting some horizontal movement. If we're pressing horizontal movement, we're getting some vertical movement. And it's very small, but we don't want that. In my case, that was because of the truncating. The truncating was dropping it like from 0.993 to 0. So if I was at like unit 2000, 0.993, it was going to read 2000. So I was dropping 1 unit every time I was doing this. I found that if I was rounding it, you wouldn't drop that off, of course. It does technically change it, but it changes it by such a small value that I was unable to notice it in any runs going forward. So long story short, instead of using the default truncate here, I went ahead and used round instead. So I could drag off the return value X and say round. Just this regular round node will work, and it returns an integer, and then just pass the X round into the X, and then make a round for the Y and pass that into the Y. Once I did that, I wasn't getting any of that offset from the controls. And so now I have a perfectly working keyboard controlled menu for the character select. Now, to make this work on the gamepad as well, we can go back to the project settings and go to input, and we can add a value for each one of these input actions. So menu right would be gamepad right. Let's actually use gamepad left thumbstick right. So if we're on an Xbox controller, the left thumbstick, if it moves to the right, it's going to trigger menu right. And we're going to use that for all these. So gamepad left thumbstick left for menu left. For menu up, we're going to do gamepad left thumbstick up. And for menu down, we're going to do gamepad left thumbstick down. And now if I save everything and I go and grab my controller. Okay, I plug this in now. And if we play it, you'll be able to see I can get through my menu here. And now I'm using my controller. I have left, right, up, and down. So now I can safely use my gamepad on here. And I can even do things like drop my coin. So now gamepad works on the menu, keyboard works on the menu for movement, dropping the coin, and everything. We're basically just using a mouse that we're mapping the values to based on the values on the input device. So there you go, guys. That's how you can get your character select screen to work with the keyboard and controller instead of just the mouse. So if you want to use the mouse going forward, again, you can. But now you have these other options for what to use as well, which gives you more freedom, and more freedom in games is almost always a good thing. So anyway, guys, thank you so much for watching. If you enjoyed this video, please subscribe or consider checking out the Patreon and YouTube membership programs. Thank you so much to all the kind souls who have already done so. I really, really appreciate it. You guys are amazing, and you keep these series alive time after time, so I am really grateful for you. Thank you so much. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community for free assistance. And anyway, guys, like I said, that is all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, my friends.